Bismillah ar-Rahman ar-Rahim. Now we're going to continue our examples of dynamics integration of vector functions. We have an example: a car starts to move from rest in a straight line from a constant or fixed point where velocity equals 3t squared minus 60 meter per second. Find average velocity vector over time interval from 0 to 3.5 seconds. Okay, as we know, v average vector equals delta x delta t in direction of c. C is the unit vector in the direction of this motion. Okay, we have to find x as a function of t. We have here, we can use definite integration of v dt, okay, from time 0 to time 3.5 second. Okay, then we have integral from 0 to 3.5 in direction of c, of course. Okay, here we have 3t squared minus 6t dt in direction of c. Okay, then we have here t power 3 minus 3t squared. We have to apply the limit of this definite integration from 0 to 3.5. Then first you have to substitute by 3.5, then 3.5 power 3 minus 3.5 power 2 is this first bracket, minus, when we substitute here t equals 0, then this bracket equals 0. Then here we have in direction of c, of course. Okay, then we have here 6.125 in direction of c meter. Okay, this is x. Okay, then we can find v average vector 6.125 over delta t. Here delta t is 3.5. okay, then we have 1.75 direction of c meter per second, and this is required to find. We have another example. A body moves in a straight line from a fixed point with initial velocity 2 meter per second. According to the relation, acceleration equals 2x plus 5 meter per second squared. Find velocity at x equals 1 meter, x at v equals 4 meter per second. Okay, here we have acceleration as a function of displacement. Then we can use half v square minus v naught square equals integration from x0 to x a dx. Okay, here we have half v square minus v naught square is 4 equals integration from x0 is 0, as it's mentioned that the motion starts from fixed point. Then we have x0 is 0, 2x equals 1 meter as it's required, and we have a 2x plus 5 dx. Okay, then here we have half v square minus 4 integration. Here we have x square plus 5x from 0 to 1. Then we have half v square minus 4 equals, by substitution here we have 1 plus 5, okay, minus 0, then we have 6. Then we have v square minus 4 equals 12, and v square equals 16. Then v equals positive negative 4 meter per second, and this is required. Okay, now it's required to find x at v equals 4 meter per second. Okay, we have this relation of v square minus 4 equals x square plus 5x. This is the main relation between v and x. Now we can substitute here v equals 4. Then we have half 16 minus 4 equals x squared plus 5x. Then we have here we have 6. Then x squared plus 5x minus 6 equals 0. By factorization we can find x plus 6, and we have x minus 1 equals 0. Then we have here from this bracket x equals negative 1, and from this one we have x equals 1 negative 6 here, and we have here x equals 1 meter. Then displacement at v equals 4 meter per second, x belongs to negative 6 and 1 meter, and this is required to find. We have another example. A body moves in a straight line from a fixed point with initial velocity 8 meter per second. According to the relation, acceleration equals 40 e to the power negative x meter per second square. Find x at v equals 10 meter per second and find maximum velocity. Okay, here we have acceleration is a function of displacement. Then we have half v square minus v naught square equals integral x naught x a dx. Then we have integral from x naught to x for 0 e minus x dx. Okay, here we have half v square minus v naught square is 64 equals integration from fixed points in x naught is 0 to x. It's required to find x. Okay, here for 0 is minus x dx. Here we have here the integration of this part is negative for 0 is minus x, and we have to apply 0 to x, the limits of this integration. Okay, then we have half v square minus 64 equals negative 40 e minus x by substitution here by x minus e as power 0. Then we have here negative 40 e is minus x minus power minus x minus 1. Okay, here we have this one. Then here we have half v square minus 32 equals negative 40 is e power negative x plus 40. Okay, then we have here half v square equals negative 40 is negative x plus 72. Okay, it's required to find x at v equals 10 meter per second. You can substitute here. Then we have here 50 equals negative 40 is power x plus 72. Then we have 40 e minus x k equals 22. Then e to the power negative x equals 11 divided by 20. Okay, then e to the power x equals 20 over 11. Then x equals then 20 over 11, and this is required to find. Secondly, it's required to find the maximum velocity. Okay, v maximum is when acceleration equals 0, okay, or dx dt equals 0. Then we have acceleration equals 0 for 0 e minus x equals 0. Okay, then e to the power x equals 0. Okay, and now we can substitute in equation relating the velocity and displacement. Here we have this one, half v square equals negative 40 e minus x plus 72 by e power x equals 0, negative x equals 0, then this term equals 0. Okay, then we have here half v square equals 72, or v square equals 144, then v equals positive negative 12 meter per second. This is maximum velocity. Okay, and this is required to find. We have this example: a car moves in a straight line from station L to end to rest at station M. According to the relation, acceleration equals a minus bx meter per second square at a, as a and b belongs to r positive. Number one, find the distance lm, distance between two stations, and find the maximum velocity. Okay, here we have acceleration as a function of displacement. Then we have half v square minus v naught square equals integral from x0 to x a dx. Okay, here we have half v square, okay, minus v naught square equals 0 as the motion starts from rest. Then we have v naught equals 0, okay, equals integral from x naught is fixed point station L, then we assume it at 0 distance, okay, or displacement, and x here it's required to find. Okay, x here is the position of M station, and then we have from 0 to x is the distance LM, then it's required to find x. Okay, then we have here a is a minus b x dx, and this is equals ax minus b over 2x square from 0 to x. Okay, then we have half v square equals ax minus b over 2 x square. This is bracket number 1, and here we have 0, then we have here ax minus b over 2 x squared. Okay, here it's required to find the distance. Then we can find, as we have v here, v final equals 0, as well as the car is at rest at station M. Then we have also v equals 0. Then we have ax minus b over 2x squared equals 0. Okay, then here we can take x as a common factor, a minus b over 2x equals 0. Then we have x equals 0, and this is refused. Okay, as the distance between L and M is not equal to 0, and we have a and b belongs to R positive, then x equals 0 is refused. Then we have a minus b over 2x equals 0, then distance LM equals x, okay, equals 2a over b, and this is required. Secondly, it's required to find v maximum. V maximum is when acceleration equals 0. Okay, then we have a minus bx equals 0. Then we will find or get x maximum when x displacement equals a over b. Okay, then as we have acceleration as a function it's of displacement, you can use this rule or relation, v square minus v naught square half equals integration from x naught to x a dx. But here we have here x equals a over b, and we have here v is maximum. Okay, then we can substitute half v naught square is 0, as the motion starts from rest at station L. Then we have half v square, okay, equals here integration from x0 is 0 to x a over b. Okay, a is a minus b x dx. Okay, then we have half v square equals, here we have ax minus bx over 2, okay, from 0 to a divided by b. Then here we have here we can substitute by a over b. Here we have a square over b minus b over 2 multiplied by a over b. Okay, minus 0, of course. If we substitute here x equals 0, then this bracket is 0. Okay, then we have here half v square equals, we can take common here 2b. Then we have here 2a square minus this a square. Then we have here a square over 2b. Okay, then we have v square equals a square over b. Then v maximum equals a divided by root b meter per second, and this is required to find. We have another example. In figure, the curve ax acceleration displacement for a body moves in a straight line with initial velocity 10 meters per second. Find v square at x equals 30 meters. Okay, here we have a relation between a and x. Then we can use this formula, half v square minus v naught square equals integration from x naught x a dx. Okay, and as we said, half v square minus v naught square equals area under the curve representing the relation between acceleration and x from 0 to 30 meter. Okay, displacement. Okay, here we have half v square minus v naught square is here we have 10 meters per second, then we have 100, okay, equals the area under this curve is the area of this triangle. Okay, here we have half base the 30, okay, times height 10. Then we have here okay v square minus 100 equals 300. The v square equals 400, and this is required to find. Here you have to take care that you have to check carefully the interval you are going to study. Okay, here we have from 0 to 30 meter. Okay, if it's required, for example, to find the v2 at x equals 15 meters, then we have to calculate the distance of this triangle only. Okay, from 0 to 15 meter. Okay, if it's required that. Okay, then you have to check which interval you're going to study. Here in this example, we're studying the interval from 0 to 30 meters. Then we used or calculated the area of this triangle, okay, over this displacement from 0 to 30 meters. We have this example. A body moves in a straight line according to the relation acceleration equals 2v, v is velocity. Find velocity in terms of time t. Okay, here we have acceleration as a function of velocity 2v, and it's required to find v as a function of t. Then we can substitute here a is dv dt equals 2v. We can separate these variables. Then we have dv over v equals 2 dt, and we can execute integration, definite integrations. Then we have integral from v naught to v1 over v dv equals integration from t equals 0 to t 2 dt. Okay, then we have here ln v, okay, from v naught to v, okay, equals 2t from 0 to t. Okay, then we have to substitute by v. First we have ln v minus v naught ln v naught equals 2t minus 0, of course. Okay, by using the or applying the properties of ln, and here we have ln v over v naught equals 2t. Then we have v over v naught equals e to power 2t. Then velocity equals v naught e to t, and this is required to find. Now it's time to check your understanding by trying to solve the following two problems. Okay, a body moves in a straight line according to the relation velocity equals 10 minus 2t meter per second. Find the distance covered during third second of its motion. Answer is 5 meters. Okay, try to solve in figure the relation between velocity and time for a body moves in a straight line. Find each of displacement and distance covered over time interval from 0 to 9 seconds in meter. Okay, the answer is displacement is negative 4.5 meter. This distance equals 16.5 meter.